Hello everyone, this is Om Prakash from CSIT branch. My ATT concept video is types of recursion. Now let's see what content is there in this topic. What is recursion? Recursive functions. Content of a recursive method. Types of recursion. Recursively defined sequences. Recursively defined functions. And recursive algorithms. Now let's see what is recursion. In simple language, recursion is the repeated occurrence of a particular event. In programming, recursion is the repeated occurrence of a procedure as a result of the procedure calling itself. Recursive procedure is the name given to the procedures calling themselves. The parameters passed each time into the function must be different. And recursion is also said as a mathematical concept that states that an expression such that each term is generated by repeating a particular mathematical operation. Here, repeating is the iterative manner to perform the same operation as the approach of the programming language C. It can be performed and or in practice within the definition part of functions. Synthetically, language provides the freedom to call a function within its body defined definition of the recursion as the logical prestative view states. Simply the iterative manner to perform any code snippet in C. But we always need a terminating condition to control the going on iterations in the following sections. We will discuss the iterative manner of recursion and the terminating conditions in bit expanded form. Recursive functions. Recursive functions are not different from the synthetical structure of the general functions that we discussed in previous sections. They have the same return type, function name, and parameters enclosed within parentheses. And the recursive function declaration is int think underscore and underscore play int or in character. We have discussed the synthetical view of the function where the return type is int, the function name is think underscore and underscore play, and within the parentheses we had defined the parameters as data type integer with another one that is of a data type character. Now let us manipulate the definition of a function that we had declared in the previous slide. From the general aspect of definition we had participated till now. Now let's see the definition for recursive function. Int underscore iflag equals to 0 underscore terminate equals to 0 int think underscore and underscore playoff int ibat char underscore chbot. Now let's open for bracket. If iflag equals to 0, printf. This is game cricket going on. Underscore iflag plus plus. If I terminate less than 6, printf hit the ball with the bat. Plus plus underscore terminate think underscore and underscore play 1 comma 0 and return to 1. Content of a recursive method. In content of a recursive method, there are two types, base cases and recursive calls. Now let's see base case. Values of the input variables for which we perform no recursive calls are called base cases. There should be at least one base case. Every possible chain of recursive calls must eventually reach a base case. The second one is recursive calls. Calls to the current method. Each recursive call should be defined so that it makes progress towards a base case. Now let's see some types of recursion methods. Single and multiple recursion, direct recursion, and indirect recursion. In types of recursion, first one is single and multiple recursion. Recursion that only contains a single self-reference is known as single recursion. Example, factorial function. Recursion that contain multiple self-references is known as multiple recursion. Example, Fibonic function. Second one is direct recursion. If a function f calls itself, that is, f calls f, then this recursion is direct recursion. Example, statics in int direct int n. If n less than equal to 0, return 0, else return n plus direct n minus 1. Third one is indirect recursion. If a function f calls g and function g calls f, then this recursion is indirect recursion. Static int in indirect int n. If n less than equals to 0, return 0, else return n plus body n minus 1. Int body int n, return indirect n. Recursively defined sequences. Example for recursively defined sequences. The sequence an of powers of 2 is given non-recursively by an equals to 2 power n for n equals to 0, 1, 2. The same sequence can also be defined recursively a0 equals to 1, an plus 1 equals to 2an for n equals to 0, 1, 2. Recursively defined functions. Here is the non-recursive definition of the factorial function n not equals to 1, 2, 3, n minus 1 into n. Here is the recursive definition of a factorial. Here f of n equals to n not equals f of n equals to 1 if n equals to 0, then n into f of n minus 1, else. The C code for the factorial function is recursive procedure for computing factorial. Public statistic int factorial int n. If n equals to 0, then it returns to 1. It is a base case. Else return into factorial of n minus 1 is recursive function. The last one is recursive algorithms. Example for recursive algorithm is recursive Fibonic algorithm. Now let's see procedure for recursive Fibonic algorithm. Fib of n non-negative integer. If n equals to 0, then find fib 0 equals to 0. Else, if n equals to 1, then find fib 1 equals to 1. Else, fib n equals to fib n minus 1 plus fib of n minus 2. Thank you everyone for your kind attention.